Um, So hi Costa. So I guess we'll start in like 5-10 minutes so that a few others can also join the session. So I guess I'll start in like at 6:10. It's 6 o'clock now. We'll start at 6:10 so a few others can join the session. Okay, so I guess since no one else is joining, I guess we can start the session. So hello everyone. So once again, welcome to the NPTEL problem solving session. So this is, I guess, our fifth session, and in this session, we'll be discussing problems related to functions and relations. So basically, one functions, on two functions, and stuff like that. So yeah, and yeah, another thing, just happy Janmashtami to everyone. So yeah. I guess we can get started with the problem statements now. So I'll just share my screen and just once again reminding you guys that if you guys have any doubts during the session or you face any technical issues, you can inform me via chat and I'll try to rectify it as to the best of my capabilities. So yeah, I guess we can get started then. I'll just share my screen and we can start discussing the questions. Okay, just sharing my screen, guys. Okay. So I hope my screen is visible to everyone. Yeah. So I hope my screen is visible to everyone now. So I guess we can get started with the questions now. So once again, I'll be assuming that you guys have gone through the lecture videos for this week, and we'll be focusing more on problem statements. I'll just be revising a few of the definitions also, but most of our focus will be on problem statements. So yeah. So first question asks us which of the following is are true for the given function. So a function f is given to us which is from R to R and f of x is given to us as x square plus 2 where R is the set of real numbers. And we want, so this is a multiple choice correct question. We want to find out whether f is injective, surjective, bijective, or it is not surjective. So these are the four options. So just to remind everyone, so what are these injective, bijective, surjective? What does this mean? So injective just injective just means 1 1. So a 1 1. So we have studied these definitions of 1 1 onto function in high school also, but I'll be revising it just once again. So injective function is just what we 1 1 functions are also called injective functions. Similarly, surjective functions are onto functions, and bijective functions are 1 1 as well as onto. So these are the definitions of injective, surjective, and bijective. So these are not exactly definitions, but let's just revise what does this 1 1 function also mean. So what's the proper how to identify if a function is 1 1? So let's say if f is a function and we have that okay if f of x1 is equals to f of x2, so implies x1 equal to x2. So for any x1, x2, if for a given function f of x1 equal to x2 implies x1 equal to x2, then the function f is 1 1. So I'm just describing the definition of 1 1 and onto functions. So this is the definition for 1 1 function that if f of x1 is f of x2 implies x1 equal to x2, then the function is 1 1. Similarly, how do we define? So maybe we should just say this is what we got injectivity. And what is surjectivity? Surjectivity is basically when do we say if a function is onto. So if range of f is equals to codomain of f, then we say that the function is onto. And I hope everyone knows what range as well as codomain means because these have been discussed in the lectures. So yeah. So yeah, just revising these definitions for everyone. And now maybe we can start with checking the whether this function is 1 1 or onto. So a high level, so this is a formal mathematical notation for checking if a function is 1, 1. But on a high level, it just means that any two values from the domain, so any two values f of x1 and f of x2 should correspond to different values. Like if x1 and x2 are different, then f of x1 and f of x2 should also be different. This is what injectivity means. Like you can just check the contrapositive of this statement. It will just imply that it will just mean that x1 not equal to x2 implies f of x1 not equal to f of x2. So this is how we generally show if a function is not 1, 1. So if for two different values the function takes the same value, then that function is actually not 1, 1. Okay, yeah, this is the high level idea, but let's just go into this question. So in this question, we are given that f of x equals to x squared plus 2. So now first we check for one injectivity for this function. So f is, maybe I should just put these definitions before the question so that you don't get confused with. Yeah. Okay. So first we test the injectivity. So you can see the domain of f is from in the whole real numbers R. And f of x equals to x squared plus 2. So suppose we take x1 equal to 1, consider x1 equal to 1 and x2 equal to minus 1. In both these cases, what we have is f of x1 will be equal to f of x2, which will be equal to 3. So even if we take two different values for x1 and x2, if we take x1 as 1 and x2 as minus 1, for both of these values, the function f of x will take the value 3, because minus 1 squared is also 1, 1 squared is also 1, and adding 2 to it will give us 3. So this means that there are two different values for which the function gives the same value, and hence the function is not 1, 1. Hence f is not injective. Okay. So first we check for injectivity, and then for surjectivity, what we need to find out is whether the range of the function is equal to the codomain. So codomain of the function is given to us as R, as function is from R to R, and we want to figure out whether range will be equal to the codomain. So would anyone like to answer in chat? This is, I guess, pretty straightforward. Uh, if whether f is surjective or not. Uh, would anyone like to answer in chat? Okay, I guess I'll just discuss this. So f will actually not be surjective, and why will this be the case? F is not surjective, and why is this? Because suppose the high level idea for this is, note that the only possible values which the range can take is of the form a perfect square plus 2. So x square plus 2 is a possible value for the range. But suppose consider the number, uh, but f is from R to R, but we want to find, but the range will be basically of the form x square plus 2. So range only contains the numbers of the form x square plus 2. Note that x square is always greater than equal to 0 since it is a perfect square of a real number. And so x square plus 2 will always be greater than equal to 2. So what I mean is, so let's just consider the number 1. Okay. If we think of the number 1, then there exists no real number x such that x square plus 2 equals to 1. Also, we know that 1 is a real number and hence lies in the codomain. So we know that 1 lies in the codomain of F, right? But we'll show that it does not lie in the range. And so range and codomain are not equal. And why is this the case? So we know that 1 lies in the codomain, but for it to lie in the range, there should be a number x such that x square plus 2 equals to 1. But this is actually not possible because this will mean that x square equal to minus 1. And no real number x is there such that x square is minus 1. Then we'll have to go into the domain of complex numbers. But note that the domain for f given to us is only the real numbers. So that's why this won't be. Uh, so that's why this won't be onto function. Thus, the range of f is not equal to. So this by this symbol I mean not equal to, like exclamation equal to. So range of f and codomain of f are not equal, and hence f is not surjective. Yeah. So Akansha has written in the chat that uh, it is not subjective. So yeah, actually, you're correct, Akansha. This was not subjective because 0 cannot be in range. Similarly, 1 can also not be in range. So good job, Akansha. Okay. So we know that it is neither injective nor surjective. So the options, so it will definitely not be bijective, obviously. So the correct answers are option A and D. And options A, comma D, yeah, correct. Okay. So now let's move on to the second question then. Okay, so what does the second question say? Yeah. So second question says consider the following table, and there is a table given to us, the name of students and their heights. And now we can think of this as a function f from the set of students. So from the set of students to the set of integers between 160 and 170. So what we are actually given is we have to think of this table as a function f from the set of students to the set of integers. So for the function f, what will be the uh, domain of f? So domain of f is nothing but the set of students, as it is given to us that uh, it is given to us that f is from set of students to the set of integers between 160 and 170. So note that between 160 and 170, we'll include both of these endpoints as well. So 160 and 170 is also included. So similarly, now codomain of f will be nothing but all the integers between 160 and 170, including both. So effectively, the codomain of f will be nothing but 160, 161, 162, 163, 164 till 170. So, and how did we define this codomain? Because it was already given to us that we can think of the function f from set of students to the set of integers between this. So this is the codomain given to us. And now we want to find the correct statements. So we again want to find out whether f is injective, f is surjective, and all the properties. So first, let's check for injectivity. So for injectivity, what do we need? We need that actually no two distinct students should have the same height, right? That's what injectivity means in essence. But here we can see that so Rohit's height is 168, Amit's height is 165, but Nitin's height is also 165. So we know that f of Amit So f of Amit is actually equal to 165, which is also equal to f of Nitin, right? And hence uh, f will not be injected. F is not injected. So I hope it's clear to everyone why is this the case that f will not be injective, because we have two students who have the same height. Similarly, surjectivity, for checking surjectivity, uh, for being surjective, range and codomain should be equal. But you can see that like the height 160 or even 161, 162, these heights are not present in the range, because range only consists of these five heights. So, but codomain consists of all integers between 160 and 170. So 161 is present in codomain, but not in the range. Hence, f is not surjective. So the correct answer will be again f is neither 1, 1 nor on 2. So like obviously f is not bijective also if it is neither 1, 1 nor 1. So option D is the only correct answer. And yeah, Akansh and Kaustav had written in this answer in the chat. So good job, guys. Your answer is correct. Okay, then. So now maybe we can move on to the next question. So third question says that let f from R to R be such that f of x equals to x by 2 plus 7. So again, we have another question of the same type. We have to check whether the function going from R to R is surjective, injective, or something. So again, let's just check for injectivity first. So for a function being injective, we had this definition, right? That if f of x1 equal to f of x2 implies x1 equal to x2, then the function is 1, 1. And we can sort of use that definition. Like generally, while disproving that a function is not injective, what we do is we take two distinct numbers such that on both of those values, the function f actually has the same mapping. Like we take two distinct x1 and x2, and if f of x1 is f of x2, then we say that the function is not injective. But note that to prove that the function is indeed injective, we have to do a bit more. What we have to do is we have to show that for any pair of numbers, if f of x1 is f of x2, then x1 should be equal to x2. So here we don't choose any specific x1 and x2. We have to show in general for all possible numbers. While disproving, we just need to give one instance of x1 and x2. Whereas while proving, we have to prove this for all x1 and x2. So I hope this sort of distinction is clear to everyone. Like while proving, we have to prove all the cases. For disproving something, we only have to like provide one counter example. So now let's see. So suppose f of x1 is f of x2. So suppose f of x1 is f of x2. What does this mean? This implies, so we just plug in the values. So f of x1 will be x1 by 2 plus 7. So this will mean that x1 by 2 plus 7 is equal to, so this will be equal to basically f of x2, which will be x2 by 2 plus 7. And from this, what we can say is we can reduce the 7, we can like deduct 7 from both sides and like multiply by 2, and we'll get that x1 will be equal to x2. So this will imply that x1 is x2. And like, so what we arrive at is if f of x1 was equal to f of x2, then these two values will be equal. And if these two are equal, this will mean that x1 will be equal to x2. So effectively, we say that if f of x1 is equal to f of x2, then x1 will be equal to x2. And hence, f is injective. Okay. Okay, so first things first, I think there's also an option which says f is not a function. But note that f will be a function. So how is a function defined? That every element of the domain should have a unique mapping in the codomain, right? And we see that for every value of the domain, every value in the domain, there's a unique value x by 2 plus 7. And this also lies in the codomain. Like if x is real, then x by 2 plus 7 is also real. So f is definitely a function. And like because these injective, surjective, and all these things are only defined for functions, not for relations. So first we need to see whether the given thing is indeed a function. And if it is, then only we can check whether it is injective, surjective, and so on. Okay. So now we check whether f is surjective. And how do we check whether f is surjective? Uh, we need to say that uh, every element of the codomain lies in the range, right? So every real number should lie in the range of this function. And how do we do this? So again, we have to show that for all possible values of the codomain, it will lie in the range also. Note that while disproving if the function is not onto, we just had to find one value which was in codomain but not in the range. But here we have to say that every value of the codomain will lie in the range. So we have to consider any value of the codomain. So consider any real number. Since codomain is R, we take any real number Y, right? Then what we can say is oh, Y equals to X. Suppose instead we put Y, like suppose we have to, if we have to find an X such that f of X equals to Y, then we'll just put like Y equal to X by 2 plus 7, right? And if this admits and in this equation, if we can find an X such that X is real, then we have actually obtained a value for which a value in the domain for which the uh, f of that value is actually equal to Y. So I hope this kind of makes sense. So now if we take this equation, this always admits a solution. And what will be the solution here? So like we have to find the value of X such that this is satisfied, right? So we have considered any real number Y and we have to find an X such that this is satisfied. So what will be the X? So we take 7 this side and multiply by 2. So we'll get X equals to 2 times Y minus 7, right? So if we put X equal to 2 times Y minus 7, then this sort of equation will be satisfied. And note that this X will be a real number. So since Y was real, like Y minus 7 will also be real. And so 2 times Y minus 7 will also be real, right? So what this gives us is that X also, so X is a real number and so X belongs to the domain. And hence belongs to the domain of F, right? And since like X belongs to the domain, so what we have is that there exists a value in the domain such that f of X is equal to Y. And this is for all possible Y. So effectively what we have obtained is that range is equal to codomain here. and hence f is surjective. So I hope this makes sense. And since f is surjective, it will also, as well as injective, it will also be basically bijective. So option B, C, D will be correct here. Yeah. Hence, options B, C, D are correct. So I hope this makes sense to everyone. Okay, so in the chat, I see that people have written answer as B. Okay, so yeah. So B is bijective, but like suppose it was a multiple correct question, then like B, C, D would be correct. But if it was a single choice, then F is bijective is the better answer to give. Right. So good job again, Akansha. So now we go to the fourth question. So fourth question says that if a function is defined as f of x equal to 2x plus 14, then the value of f inverse 25 is. So we are given the function as f of x equal to 2x plus 14, and now we have to find the value f inverse 25. And what does inverse actually mean? So inverse actually means that like this has also been covered in the lectures, but basically what we need is we need to find an x such that f of x is actually equal to 25. So instead, instead of putting x, so what we need to find out is we need to find a value x such that the value the value 25 is actually equal to f of x. This is the definition of inverse, right? So what this gives us is this means that 2x plus 14 is equals to 25, and this gives like x will be equal to 11 by 2, right? Which will be nothing but 5.5. So x equals to 5.5 will be somewhat the correct answer. So I hope this is clear to everyone. So Akansha has written in the chat 11 by 2. So good job, Akansha. So once again, guys, these are very introductory level questions, so I'm going a bit fast. But if any of you has any doubts at any point, like do feel free to ask in chat. Like I'll try my best to explain it again. You can ask as many times as you want. So yeah. Uh, okay, then I guess we can move on to the fifth question. So fifth question says that suppose a set C has cardinality P and a total of 5040 bijective functions. Then what is the value of P square? So we are given that the number of bijective functions. So what we are actually given is there C has a total of 5040 bijective functions. So what does this mean? This means that number of bijective functions from C to C is 5040. So the number of bijective functions where the domain is also C and codomain is also C, this is equal to 5040. And what we actually need to find out is, so first we'll need to find out the cardinality of C, right? Cardinality of C is P, and only after finding P will we be able to find P square, right? So we first find out. Okay. So number of bijective functions from C to C is equals to. So does anyone know like if the cardinality of C is like in terms of cardinality of C, what will be the formula for number of bijective functions? I believe this has been covered in the lectures also, but uh, just seeing if you guys remember this. So for any set S, maybe I should uh, reformulate, like otherwise you'll get confused between C and C. But yeah, so this is in general. So for any set S, number of bijective functions from S to S, what will this be equal to? Okay, so yeah, Akansha is writing P factorial. So good job, Akansha. But that's actually correct. But like since I'm just assuming for any set, not just this set C, I'll just better write it as cardinality of S factorial, which will be like P factorial in the case that this set is actually equal to the set C, right? So what we can say is, hence we can say that the cardinality of C factorial is equal to 5040, which implies that cardinality of C was actually equal to P. So this is nothing but P factorial is 5040. And if P factorial is 5040, then what's the value of P? So it's not too difficult. Just P will be actually equal to 7 in this case. Like you can just see because 5 factorial is, I guess, 120, 6 factorial will be 720, and 7 factorial will be equal to 5040. So we arrive at the value P equals to 7. And since P equals to 7, the value of P square is P square is 7 square, which is 49. So maybe I'll just point this. Yeah. So I hope this is clear to everyone. Like if a set has cardinality P, then there are P factorial total possible bijective functions, and it is given to us that this P factorial is equal to 5040. So yeah, if P factorial is equal to 5040, then P will be nothing but 7. And so P square is 7 square, which is equal to 49. Okay, so I guess it makes sense. Then we can move on to the sixth question. So sixth question says that find the largest possible domain and range of the following real valued function. So we are given a function f of x equal to square root of 3 minus x. And now what we need to find out is the largest possible domain and range, like the maximum possible set for the domain and range. Like note that x equal to 1 will is also a domain, like x only takes the value 1. But we need to find out the domain of the largest possible size. So any idea like what will be the domain? Would anyone like to answer in chat? Like if a function is square root 3 minus x, and we are given that the function is real value. So we can't include any complex numbers and stuff in the range also, neither in the range nor in the domain. So what will be the largest possible domain keeping this function real valued? Okay, so Akansha is saying in the chat that the domain should be from -3 to 3. Uh, Akansh, like you're close to the correct answer, but one part of your answer is correct, but the lower bound is actually, I think, not totally correct. Like, what would happen if even if instead of -3, x could take the value -4? Like 3 minus of -3 will anyways be +6, right? Okay, so Kaustav, I think, is just copying and pasting Akansha's answer in the chat. But Akansha's answer is like not correct here, Kaustav. Uh, so, so what I mean is, here maybe I can just explain it to you guys. So what we are given is f is a function, and we are given that codomain of f is R. We are given that the function should be real valued. So codomain of the function is R. And now, okay, we need to find out the domain, right? So domain says that, so domain should include only those x such that f of x should be real, right? And when will f of x be real? It will only be real when the value in the square root is greater than equal to 0. Because square root of negative numbers is not defined when we are only talking about when we are only talking about real numbers and not complex numbers, right? So this actually means that 3 minus x should be greater than equal to 0, right? And if 3 minus x is greater than equal to 0, this implies that x will be less than equal to 3, right? So the only constraint which we can derive here is x is less than equal to 3. And like it need not be necessarily greater than equal to minus 3. Like even if we put x as minus 10, then also this value will come out to be 3 minus of minus 10 will come out to be 13. And square root of 13 is a real number, right? So actually the correct answer would be the range of, so the domain of f is nothing but from minus infinity to 3. And note that we have a closed bracket at 3 because at x equal to 3 also, this function is well defined. And obviously we always have open brackets at infinities. So this will be the domain. Okay, so I hope this makes sense now, Kansha. Why is domain of f? Okay, cool, it makes sense. Nice. And now talking about the range. So range is nothing but like all possible values over the domain, right? So if x is equal to 3, then this takes the value 0. Similarly, like for any value greater than 0, uh, so for any value greater than 0, this square root function uh, will like so what I'm claiming is any positive real number can be uh, will lie in the range of f. Like we know that square root function always gives us uh, okay, so what I'm trying to say is the square root function is never negative, right? So square root function has this property that like even if we say root 4, then we only mean plus 2. Like root 4 does not mean minus 2. Root 4 is always equal to plus 2. Like root of a number x is always equal to like a modulus of square root of x. So I mean, so set of all possible values over the domain, right? And what I'm trying to say is any positive value, we will be able to make any positive real number will lie in the range, because any positive real number, let's say if we have y, then y will be equal to square root of 3 minus x, and from that we obtain that x will be equal to 3 minus of y square. So putting x equal to 3 minus of y square, we will be able to obtain that real number. And like 3 minus y square will also lie in the domain, as can be seen. So this will be nothing but set of all positive real numbers. And so domain is equals to, and range is equals, and so range is equals to like from 0 to infinity, and infinity of open bracket and 0 close bracket, because 0 will also be included at x equal to 3. So does this make sense, guys? Like the main thing which I want to point out here is square root of a number is always positive. Like this root function always returns a positive value. So if someone asks you what's the value of root 4, then you don't say plus minus 2, you only say plus 2. So here the range cannot contain any negative values, and all positive values can be made using this function. As I already told that suppose there is a positive real number y, which is equal to square root of 3 minus x, then we can say that 3 minus x is equal to y square, and from that we obtain x equal to 3 minus y square. So at value x equal to 3 minus y square, uh, we will obtain that value y by putting in this x. So, so I hope I made sense. If not, then you can obviously inform me in chat. Otherwise, I'll just assume that you guys have understood this and so the correct answer here is that domain is from minus infinity to 3 and range is from 0 to infinity. Okay, then maybe we can move on to the seventh question. So seventh question says that if f and g are functions from R to R and f of x is equal to 3x squared plus x minus 13 and g of x is equals to 20 upon 3x plus 8, then what's the value of FOG of 12? So if FOG, I hope everyone has seen the lecture. So FOG denotes the composition of functions. So this means that f of g of, so we need to find out f of g of 12. So note that we first need to find out f of g of 12 means we first find out g of 12 and then put this value g of 12 into f and see what the answer comes out to be. So one thing to note here is uh, note that FOG is actually not equal to GOF. So one might think that maybe I can replace the orders. I can first compute f of 12 and then put f of 12 into g. So note that this is always not possible. Like FOG will not be equal to GOF in a lot of cases. So always compute in the order asked. So this is a silly mistake which people sometimes do. Like they sometimes reverse this order thinking that it won't affect anything, but this is like totally incorrect. So never do this, guys. So always compute in the order asked. Okay. So uh, so let's find out g of 12 first. So we first find out g of 12, and then we put the g of 12 into f and find out that value. So g of 12 will be equal to, so g of x is 20 upon 3x plus 8. So g of 12 will be nothing but 20 divided by 3 into putting x equal to 12 plus 8. And this will be equal to 20 divided by 3 times 12 is 36. 36 plus 8 is 44. So this will come out to be something like a 20 by 44. And this will be nothing but like simplifying it. This will be 5 by 11, right? So g of 12 will come out to be 5 by 11. But what we actually need to find out is f of g of 12, right? F of g of 12. And what will this be equal to? So we know that g of 12 is 5 by 11. So we just replace g of 12 by 5 by 11. So this will be f of 5 by 11. And this will just be equal to like, we put 5 by 11 in this function, like 3x squared plus x minus 13. So 3 times 5 by 11 squared plus 5 by 11 minus 13. And this is our answer. Right? So what does this come out to? Would anyone like to like, compute and answer in chat? I can do it along with you. So this will be 25 by 121. So this will be 3 times 25 by 121 plus 5 by 11 minus 13. And this will be something like 75 by 121 plus 5 by 11 would come out to be 55 by 121. And we subtract 13 from it. Does this simplify? I don't think it simplifies to anything. So 70 plus 50 is 120. So this will be 130 by 121 minus 13. Oh my God. This is a very bad expression. And this will actually come out to, maybe I should calculate. Uh, so what does this come out to be in terms of fractions, guys? You can do it using your calculators. Uh, this will come out to be 30 times 121. 13 times 121 minus 130. So it will be something like minus 1443 by 120. So something like this. So this will be our answer here. So this will be the value f of g of y. So I see that the chart is a lot less responsive than usual today. So are you guys able to follow what I'm doing in all the questions, or like there can be two things why the chart is not as responsive. One might be that everything is so easy that everyone is able to understand, and second reason might be like no one is able to understand. And I believe the second option is more likely. But so is everyone able to follow what I'm doing till now? Kaustav, Akansha, Isha. Okay, so Akansha says that she's able to follow. So I'll just be assuming that, yeah, others are also able to follow. If because if you don't inform me, guys, then there's no way from knowing if you guys understood or not. So yeah. So let's come to the eighth question then. So eighth question again says, let us define a function f. So again, this is a function f, but this function is defined a bit more trickily, like it's defined in parts. So a function f from z to z, and note that z denotes the set of integers. So z means the set of, okay, so it has already been given that z is a set of integers. So so we have a function from whose domain is integers, domain is a set of integers, and codomain is also a set of integers, and this function is defined as follows. So f of x is equal to x by 2 if x is even, and f of x is 0 if x is odd. So for the numbers 1, 3, 5, 7, 9, 11, and so on, so for all the odd numbers, this function takes the value 0. But for all the even numbers, so for the number 2, this function takes the value 1. For 4, this takes the value 2. And for all even numbers, this takes the value x by 2. So you can see that clearly, first of all, this is a function like since 0 is always an integer, so it always lies in the codomain. And if x is even, then x by 2 is also an integer. So this also lies in the codomain. So we know that for every x, f of x lies in the codomain, and so this is a function, and there is f of x is always unique. So we know that f of x is a function. Just for a sanity check, we did this. And now let's see whether the function f is 1, 1 or on 2 or so on. So let's check for injectivity. So what do you guys think? Is this function 1, 1? So is this function f of x 1 or not 1? Okay. So Akansha says that it is not 1 So correct, Akansha. Not injective. And why is this the case? Because you can see that for all odd numbers, this function takes the value 0, right? But for 1 we need that for all different numbers, the f of those numbers should also be different. Uh, this is because f of 1 is equal to f of 3, which is 0. F of 1 and f of 3 both are 0, but for 1 these should have been different. Right. Now let's check for surjectivity. So is this function onto? So we have that f of x is x by 2 if x is even, and 0 if x is odd. So is this function onto or not onto? So Kansha is saying that it is onto. So good job, Kansha, you're correct. So this function is onto. It is onto. And why is this the case? Consider any integer y. So consider any integer y lying in the codomain, right? So consider any integer y. Uh, y will lie in the codomain, right? And now we need to show that there will exist an x such that f of x will be equal to y. So now consider the x. Consider the number x equals to 2 times y. So consider the number x equals to 2y, and what we will have here is then as x is even, like x equal to, since x is equal to 2y and y is an integer, x is even, right? So what this means is f of x will be equal to x by 2, and x was put in as 2y, so we will have it as equal to 2y by 2, which will be nothing but equal to y, right? So for any y, we obtain a number in the domain such that f of that number is actually equal to y. And so like range will be actually equal to codomain here. And so this function is on. Hence f of 2y is equal to y for any integer y. So range of f is codomain of f. So I hope this makes sense that range will be equal to codomain because for every element y in the codomain, we are able to find a number which is like 2y, such that f of that number is equal to that. Okay, so we get that this f is not 1 but it is onto. So onto but not 1 So option A is correct. Hence option A is correct. Okay, then I guess we can move on to the next question. So this says that the relation R is defined as R equals to x comma y, such that x comma y are natural numbers and x plus y is equal to 5. So we are defining a relation uh, between a tuple x comma. We are defining a relation where x and y are natural numbers and the tuples x comma y are of the form like such that x plus y is equal to 5. So we need to note that this is actually a relation, but a range is defined for a function. So first we'll sort of need to show that this relation is also a function, which is not too hard to see actually because for any x, uh, like we have that x plus y equal to 5, right? So y will be nothing but equal to 5 minus x. So for any x, we have a unique image of that x, which is equal to 5 minus x. So it is easy to see that that r is a function as y equal to 5 minus x, and hence uh, uh, every element of the domain has exactly one image in the coordinate. So something like this, because like again x is a natural number, so 5 minus x will also be a natural number, but okay, but this will only be okay. So maybe I should not define it like this. Okay, let's leave it at that. But what I'm trying to say is we need to find the tuples x comma y such that both are natural numbers and x plus y equal to 5, right? So what will this relation R consist of? Let's just try to find that only. So this relation R will consist of so x and y both should be natural numbers. So note that 0 is not a natural number. So 1, 2, 3, 4, 5, these will be the possible natural numbers. So like what I'm trying to say is this tuple will be part of the relation R. This 2 comma 3 will be part of the relation R. 3 comma 2 will be part of the relation R. And 4 comma 1 will be part of the relation R. And no other tuple will be part of the relation R. And why is this? Because x plus y, x and y both are natural numbers and x plus y should be equal to 5. So if x was 5, then y will have to be 0, but 0 is not a natural number. So that's why the relation R only consists of these values. Okay, so the relation R consists only of these values. And so now we can you can see that for each x, there is only one y. So for x equal to 1, there is only uh, one tuple, like uh, 1 comma 4 is only present. Like there is no other tuple in which x value is 1 and y value is something else, right? So 1 comma 4, 2 comma 3, 3 comma 2, 4 comma 1. So for every unique x, there is only one value of y. So that's why this R is a function. It is easy to see that R is a function, right? So first of all, like just for sanity check, we described that it is indeed a function. And now we need to see what is the range of R. So what will be the range? Range is nothing but the values of uh, the y values here, right? The y values of all these tuples will be the range. Because like this denotes that f of 1 will be equal to 4, f of 2 will be equal to 3, f of 3 will be equal to 2, and f of 4 will be equal to 1. So note that only 1, 2, 3, 4 are the values in the domain. And so 4, 3, 2, 1 are the only values in the range. So hence, range is nothing but these values 4, 3, 2, 1. 4, 3, 2. Because the y values are part of the range, whereas x values are part of the domain. So we get that range is equals to 4, 3, 2, 1. I hope this makes sense. If so, then maybe we can move on to the next question. So again, so 10th question says that let A be a set with cardinality n and B be a set with cardinality m. and there are a total of 3024 functions from A to B. Then what are the values of n and m respectively? So we are given that there are a total of 3024 functions from A to B. And now we need to find out these values of n and m. So note that before finding out these values for n and m, we'll sort of need to find a general formula or something like if A is a function, if A is a set with cardinality n and B is a set with cardinality m, how many total possible one-to-one functions are possible from A to B? Like we know that this number is equal to 3024, but in terms of n and m, what will be the formula? So this has also been somewhat discussed in the lectures, this formula, but I'll just again total number of one-to-one functions from A to B. So what will this be equal to? So if cardinality of A is n and cardinality of B is m, then what will be the total number of possible one-to-one functions from A to B in terms of m and n? Would anyone like to answer in chat? Okay, I guess so. This is actually not too hard. Okay, so maybe one thing to note first is since we are interested in finding out the one-to-one functions from A to B, so note that since so if there exists a one-to-one function from A to B, then note that always cardinality of B, if there exists a one-to-one function from A to B, then cardinality of the set B will always be greater than equal to cardinality of the set A. Because every value of A, every distinct value of A should correspond to a distinct value of B, right? So cardinality of set B should be at least as large as A. Since there exists one-to-one function from A to B, hence cardinality of B should be actually greater than equal to cardinality of A, which just implies that M is greater than equal to N. So first things first, we know that M is greater than equal to N. Cardinality of B was M, cardinality of A was N. We know that M is greater than equal to N. And now we want to find out the total number of one-one functions from A to B. So uh, finding out this is not difficult actually, because we know that uh, for any value of A, like for any value x of A, we need exactly one value from B, right? So there are n values in A. So out of the m values of B, we need to choose n values. And now we need to assign these n values uh, to the n values of A. So we can actually permute these n values. So it will be something like this, that m choose n multiplied by n factorial. And this is because first we choose the range. So you can think of this in two steps. So first we choose the range of the function. So what elements will belong to the range? So since A has cardinality n and it is a one-to-one function, so range should contain n elements. And so we choose n elements out of total m elements of B. And now we can sort of permute these n elements over each other uh, for giving us different possible functions. This has been covered in the lectures as well, so I won't go into too much details. But yeah, so this is the high level idea. And this is given to us to be equal to 3024, right? And from this, we need to find out the values of m and n. And note that m and n are integers. So first, we just do a factorization of 3024. So now we'll need somewhat of a guessing, like what, since these are two variables and one equation, so like you can't solve it directly, but we also need to use the constraint that m and n are integers here. because cardinalities are always integers. So we'll need to somewhat guess two integers such that this value comes out to be 3024 and also m is greater than equal to n. So how do we do this? We just do the prime factorization of 3024. This will come out to be 2 times 2 times. So 3024 is, if we divide by 2, it will be 1512. And 1512 when divided by 2 will be 756. And when this is divided by 2, this will give us 375, 378. I think this will be something like this. And 378 divided by 2 will give us uh, 189. And if 189 we have, then it can be divided by 3 to give us 63, then 21, then 3 again, then 7. So I'm not doing anything fancy. I just calculating orally like what will be the prime factorization for 3024. So note that 3024 will be nothing but equal to this. You can easily verify it yourself also. And note that we need to convert it in some form of like m choose n times n factorial, right? And maybe we should simplify this also. Like, what does m choose n times n factorial actually mean? So m choose n is nothing but m factorial divided by n factorial times m minus n factorial. And this n factorial is also in multiplication with it. So this is nothing but m factorial divided by m minus n factorial, right? And like, this is nothing but maybe m times m minus 1 times m minus 2 till m minus n plus 1. So m times m minus 1 times m minus 2 times till m minus n plus 1 is equal to 3024. I just simplified this expression. So some consecutive numbers. So we need to write 3024 as a product of some consecutive numbers, right? These are all consecutive integers. And if I divide it like this, then actually I think we can divide it in terms of consecutive numbers. And what will those be? So for which consecutive numbers can we obtain? Okay, so we have the 7. Maybe we can take 3 and 2. So we will have 6 from this. We'll have a 7. We'll have a 9 from this 3 and 3. And we'll have a 8 from this 2 and 2 and 2. So you can see this yourself also that this will come out to be 6 times 7 times 8 times 9. You could have also just checked different values of m and n and found out like when does 3024 come out to be equal to what possible m and n. But I just try to do it a bit more efficiently. And if I can write 3024 as 6 times 7 times 8 times 9, then from this, like this is also equal to like m times m minus 1 till m minus n plus 1, right? So from this we can get that m will be equal to the largest of these. So m will be 9 and m minus n plus 1. M will be 9 and m minus n plus 1. This value will be equal to this 6. And from this we can get that. So putting m worth 9, we get that n is actually 4. So m is 9 and n is 4. This will be the correct answer. Okay, so I hope this made a bit of sense. Why did we do this? Like we just wanted to write 3024 as a product of some consecutive integers, and from that we were able to obtain the values of m and n. So yeah. Okay, then. So these were the uh, 10 questions which were more or less like not too hard and were more or less straightforward from the lectures. But we have two questions more which are a bit more on the challenging or difficult side. I guess we should discuss these also since we have time. So 11th question just says that prove that the set -1 to 1 has the same cardinality as the set 1 to 3. So uh, what we need to show is that the set of real numbers from -1 to 1 actually has the same cardinality. Okay, so I think Isha has a doubt. She has raised her hand. So, um, so Isha is typing something in the chat. Okay, so Isha is asking how do we get m equal to 9 and n equal to 4? Okay, so Isha, so we had this total number of functions, one functions from A to B was actually equal to this, right? M times m minus 1 times m minus 2 till m minus n plus 1. So this was the total number of one functions from A to B. And note that these are just consecutive integers of whom we are taking product, right? So we have some consecutive integers on who we take product and we obtain the total number of functions from A to B. And this is given to us as 3024. So we kind of need to break down 30. So there can be more than one way. I don't know, like it may be possible to write it in more than one way, but we just wanted one possible value for n and m, right? So I just tried to write down 3024 as a product of some consecutive integers. And this was one way which I was able to obtain that 3024. I wrote it as 6 times 7 times 8 times 9. Like it, there may be some other way also to write it in some terms of consecutive products, but like we just need one of those. So if I have this 6 times 7 times 8 times 9, and this is actually equal to this value, m times m minus 1 till m minus n plus 1, what I can say is note that in these consecutive integers, m is the greatest number in these product of terms. So, and here the greatest number is 9. So m will correspond to 9 here. And similarly, m minus n plus 1 is the smallest of those, of these numbers in the product. So m minus n plus 1 will be equal to 6 and m will be equal to 9. So m is 9 and m minus 1 is 6. And from these equations, we get like m was 9. So putting 9 here, I get n is equal to 9 plus 1 minus 6, which will be 4. Uh, does this make sense, Isha? I can try to explain it again also. Okay, you understood this. Nice. Okay, I guess so. We can move on to the 11th question then. So 11th question is a bit more on the difficult side or a more technical side. So 11th question says that we have to show that uh, the set of real numbers from -1 to 1 has the same cardinality as the set of real numbers from 1 to 3. So this might seem counterintuitive at first because, okay, I don't think it seems like. So what I was trying to say was, I can kind of change the question also. So the set of real numbers from -1 to 0 has the same cardinality as the set of real numbers from 1 to 3. Suppose we have to show this kind of thing. Like this is the question. And this sort of seems counterintuitive because the length of this interval is only 1 because like -1 to 0 has only a length 1 because like 0 minus or minus 1 is 1. Whereas this has a length of 2. Like the difference between upper bound and lower bound is 2 here, and here the difference between upper bound and lower bound is only 1. So it might seem that like this should have twice the cardinality as this set. Note that this is an infinite set and this is also an infinite set because the number of real numbers between minus and 0 is infinite. Similarly, these are also infinite. But it seems that this should be twice the infinity of this, right? Because it has a lot more numbers than this interval. But what we can actually show is that these two sets have equal cardinality, and this is something which is like very interesting from mathematics point of view. So note, so what this actually implies is uh, the set of the set of real numbers between this certain interval has the same cardinality as the set of real numbers between this interval, even though this interval is larger than this, but the cardinality of the real numbers is still the same. And now we'll go about showing this thing. And like when dealing with infinite sets, we need to deal it in terms of injective and surjective function. So just for a revision, what we were doing. So if f is a function from a to b, suppose f is a function from a to b, then we know that if f is injective, if f is an injective function, then cardinality of b will be greater than equal to cardinality of a. And why is this the case? Because every unique value of a should correspond to every unique value in b. So cardinality of b should be greater than equal to a. Similarly, if f is surjective, then what we can say is cardinality of a should be greater than equal to cardinality of b. So if there exists a function f from a to b such that f is injective, then we know that cardinality of b should be greater than equal to cardinality of a. Similarly, if f was surjective, then cardinality of a should be greater than equal to cardinality of b. And like this is true because like every unique value of a should correspond to a unique value of b. And like this part is true because uh, range, if f is surjective, then range is equal to then range of the function is actually equal to the codomain, right? And range will be range will correspond to cardinality of A. And so this should be greater than equal to cardinality of B, which is like the codomain. Like B is the codomain. So cardinality of B is like cardinality of the codomain. And so like cardinality of A should be greater than equal to cardinality of B. Okay, so first of all, let us be clear with these two things. Uh, like we can only proceed further after these two things are clear. Like why is this the case and why is this the case? So if there are any doubts, you should ask right away. Like if you don't understand uh, why these two statements hold, because these are the central point in our proof now. These will be the central point in our proof. So I'll just assume that you guys have understood. So we see that uh, so from this, if this statement is true, then we sort of obtain a recipe for showing. Then we get an idea like how can we show that two functions have same cardinality or different cardinalities or so on. So like to show that any two sets, okay, S1. So consider any two arbitrary sets S1 and S2, and suppose we want to show that they have the same cardinality. Uh, what we can do is we can show that cardinality. Okay, we can show that cardinality of S1. So if two sets have same cardinality, then what this means is that cardinality of S1 is less than equal to cardinality of S2, and cardinality of S1 is greater than equal to cardinality of S2. So for showing that two sets have the same cardinality, we can show that cardinality of S1 is less than equal to S2 and cardinality of S1 is greater than equal to S2. If these two statements hold together, then we can say that these two sets have the same cardinality, right? And to show that cardinality of S1 is less than equal to S2, what we can show is there exists an injective function from S1 to S2. Okay, so if from this statement we get an idea, like suppose instead of B I said S2 and instead of A I said S1, then if f is a function from S1 to S2 and f is injective, then cardinality of S2 will be greater than equal to cardinality of S1. Right. Okay. So maybe I should just replace it by S1 and S2x. Yeah. This is. I hope this is clear. Like I just replaced A and B by S1 and S2. And now, if we need to show that N2 sets S1 and S2 have the same cardinality, we can show that S1 is less than equal to S2 and S1 is greater than equal to S2. Now, to show that cardinality of S1 is less than equal to cardinality of S2, uh, one trick that can be employed is we can find an injective function from S1 to S2. So suppose we find an injective function f1 from S1 to S2. Then we can say that cardinality of S1 is less than equal to cardinality of S2. And similarly, okay, so similarly, to show that cardinality of S1 is greater than equal to cardinality of S2, we can find a surjective function f2 from S1 to S2. So this is somewhat of an idea. So this is the high level idea which we'll be following. And this follows from this observation. Like this is an observation that if f is a function from S1 to S2 and if f is injective, then cardinality of S2 is greater than equal to S1. Similarly, if f is surjective, then cardinality of S1 is greater than equal to cardinality of S2. So now suppose we need to show that two sets have the same cardinality, then we just need to show that cardinality is less than equal, first is second, less than equal to cardinality of second, and cardinality of first is greater than equal to cardinality of second. Now to show this claim that cardinality of first is less than equal to cardinality of second, we just need to find an injective function from first to second. If there exists an injective function, then using this observation, we can claim that cardinality of S2 is greater than equal to cardinality of S1. Similarly, if we can find a surjective function from S1 to S2, then we can say that cardinality of S1 is greater than equal to cardinality of S2. So to prove that cardinality of S1 is actually equal to cardinality of S2, we just need to find appropriate functions f1 and f2. Okay, maybe I should remove the 12th question because it is along the similar lines and it won't as much. And we'll cover this 11th question. So if we are able to find two such functions, if we are able to find two such functions f1 and f2, which both go from s1 to s2, but f1 is injective, but f2 is surjective, then we are done. And the two sets here are from -1 to 0. So consider we are given that S1 is equal to -1 to 0 and S2 is equal to 1 to 3, the set of real numbers from 1 to 3. And now what we have to do is the recipe which we derived, we just have to find we first have to find an injective function from this to this. And second thing is we need to find a surjective function from this to this. So I hope what I just said makes sense. So let's find out the injective function first. So consider f1 of x. So we need to find a function f1 which is injective, whose domain is from -1 to 0 and whose codomain is from 1 to 3. So I don't think it's too hard to see that for finding an injective function here, injective function is just one function. So what we can do is this can just be equal to x plus 2, right? So if f1 of x is equal to x plus 2, then this will be injective. And why is this the case? Because if f1, so my claim is that f1 of x is injective because, okay, so first of all, we note that since x lies from -1 to 0, so x plus 2 will lie from 1 to 2. X plus 2 will also always lie between 1 and 2. And so it will always lie in a part of codomain, right? Codomain is from 1 to 3, whereas range is from 1 to 2. So this is definitely a valid function for us. But we now need to show is that this is injective. Yes. So f1x is injective because f1 of x1, if f1 of x1 is equal to f1 of x2, this implies that x1 plus 2 will be equal to x2 plus 2. x1 plus 2 will be equal to x2 plus 2, and this will give us that x1 equal to x2. And so we know that this function f1 of x equal to x plus 2 is injective. So we obtain that cardinality of S1 is less than equal to cardinality of S2. So we have obtained this from this function. Now we need to find out. So we have found out an injective function. Now the second thing to find out is a surjective function, right? From S1 to S2. So consider f2 of x. Okay, so we need to find out a surjective function from this set to this set, right? And surjective function just means that it should take, the range should be equal to the codomain. So codomain is 1 to 3 and range, the domain is -1 to 0. So again, if we make a linear function which at x equal to -1 takes the value 1 and x equal to 0 takes the value 3, then we'll probably be able to find. So here what I claim is if I take the function 3 by 2 times x, okay, so plus 3. Does this give us something? Okay. It does not give us the. Okay, so what I'm trying to find out is a function, basically a linear function, which goes from -1 to 0 to 1 to 3. And since it's so, I'm trying to find out a function which at x equal to -1 gives me the value 1, and at x equal to 0 gives me the value 3. If I have this sort of function, it will be linear, and so it will be actually cover all the values in the range or something like this. So uh, just a second, guys. This will be 2 by 1. So it will be something like that. I think yes, this will come. So consider the function f2 as 2x plus 3. And now you can kind of show that this function will be surjective. And this is because for any real number y between 1 and 3, we get that y equal to 2x plus 3. And so x equals to y minus 3 by 2. And note that y lies between 1 and 3. So this value of x will lie between putting y as 1. This will be -1. And at y equal to 3, this will be 0. And these are the two bounds on x, right? -1 and 0. So so actually, like, all the values of x will lie in the domain, which lies in the domain for all y between 1 and 3. So we can always obtain an x such that f2 of x will be equal to y, as long as y lies between 1 and 3. So I hope this kind of part is clear. This might be a bit confusing, but we are just proving surjectivity here. And so if we have this one, if we have this surjective function, then we can say that cardinality of S1 is actually greater than equal to cardinality of S2. And so from these two claims, we obtain that cardinality of S1 is actually equal to cardinality of S2. So cardinality of S1 is actually equal to cardinality of S2. Yeah, hence proof. Okay, so yeah, and this is how we kind of show that these S1 and S2 actually have the same cardinality. Even though this interval is twice the length of this interval, still these have the same cardinalities. And this we show by, and this was made possible because of this observation, that there, if there lies an injective function from S1 to S2, then cardinality of S2 is greater than S1. And similarly, if there's a surjective function, then this happens. So once again, just giving you guys the high level idea of what we did. So we considered this as the first set as the domain, the second set as the codomain. And then we found out one function which was injective, considering this domain and codomain. And secondly, we found another function F2, which had the same domains and codomains, but this was surjective. And from these two claims, and if we are able to find indeed these two functions, then we will be able to claim that cardinality of these both sets are equal. And so, yeah, this might be a bit confusing. Like this problem is not similar to any of the problems which would have been discussed in the lecture videos. It's a bit more involved and mathematical, but like this shows the beauty of the injective and surjective functions and so on. So I would recommend you guys to after I upload this video and these notes to look at this again so that you can get a better idea of what we were doing. But Other than that, if there are any doubts still, you can ask me via chat, or else like I don't have any other problems to share right now. So uh, we can stop the session also. So if there are any doubts in this question, guys, or in any of the previous ones, you can ask me via chat, or otherwise I'll just assume that uh, no one has any doubts, and then we can close the session. Yeah. So this was a bit more involved, but yeah. Okay, I guess since okay, Isha is typing something in the chat. Okay, so Isha is just saying that she has to. Suvarna Lakshmi is also typing something. Okay, so Suvarna is asking to explain this again. So Suvarna, I'll try to explain the high level idea first. Then we can come to uh, the main thing. So what we have to show here is that if we have to show two uh, if whenever we have to show cardinality relations between two infinite sets, like here this is an infinite set because number of the real numbers between -1 and 0 are infinite. Similarly, real numbers between 1 and 3 are infinite. When we have to compare their cardinalities, we do it using injective and surjective functions. So first of all, this is our observation, uh, and this is not too hard to see that if f is a function from S1 to S2, like here S1 is the domain and S2 is the codomain. So forget these intervals and anything. This is just a general observation that if f is a function from S1 to S2 and f is injective, then it will always be true that cardinality of S2 will be greater than equal to cardinality of S1. And if f was surjective, then mod S1 will always be greater than equal to mod S2. This observation always holds. Like it doesn't matter what these two sets S1, S2 are. Forget we are talking about intervals or anything. Okay. So if this observation always holds, then we kind of get an idea to compare. So for comparing, then we get an idea of how to compare cardinality of two sets. So for any two sets S1 and S2, if we have to show that they have the same cardinality, suppose we have to show that mod S1 is actually equal to mod S2, then we can essentially show it in two parts. We can say that mod S1 is less than equal to mod S2 and mod S1 is greater than equal to mod S2. If we are able to show these two claims, this means that mod S1 will be equal to mod S2, right? So we need to prove these two independently. And for proving this part that mod S1 is less than equal to mod S2, what we can do is we can find an injective function f1 from S1 to S2. Because if an injective function exists from S1 to S2, then we will get that mod S2 is greater than equal to mod S1, which we actually needed to show. And similarly, to prove that mod S1 is greater than equal to mod S2, we can find a surjective function. And from surjective function, we will be able to obtain mod S1 is greater than equal to mod S2. So we just need to find these two functions f1 and f2. So this is our high level idea. And after this has just some mathematical calculations. So we have this S1 as -1 to 0 and S2 as 1 to 3. So now we just need to find out an injective function whose domain is this and codomain is this. And we have to then find a surjective function whose domain is this and codomain is this. So this is more of a, now we have reduced it. So the high level idea was this, and now we have reduced it to a mathematical problem that find an injective function from this to this. And Similarly, find a surjective function from this to this. Those two functions might be different from each other, but one has to be injective, other has to be surjective. And now it's just pure maths. Like first, I considered the function x plus 2, and this was actually injective. And now we have to find a surjective function, and this function 2x plus 3, you could calculate it for surjective. So this is just plugging in the actual functions and then just calculating like if the function is injective or surjective. So this is more of a mathematical part which you can review later also. And this is not the key component of this proof. The key component of this proof is this idea, this high level idea which you should be able to understand. That to prove that mod S1 equal to mod S2, we break it down into proving mod S1 is greater than equal to mod S2 and mod S1 is less than equal to mod S2. And for proving one of these, we find an injective function. For proving another of these, we find a surjective function. Does this high level idea make sense? Suvarna Lakshmi? Uh, okay, so this high level idea makes sense to you. Nice. So as long as this high level idea is clear, afterwards it's just maths, which applies these high level ideas into this specific question. You can review this maths later also when at when looking at these notes. But the main thing, like this idea, should be clear to you right now. Suvarna Lakshmi is typing something in the chat. Okay, nice. So you understood. Okay, then. So I guess uh, so since this question is also clear to everyone, so I guess there are no more doubts then. So I guess we can close the session, guys, and like I'll stop the recording and you can also leave the session. So just once again, thanks for joining everyone. We'll hopefully see you guys next week. Same timings, Monday, 6 to 8 p.m. And yeah, goodbye, guys, and happy Janmashtami to all. Bye bye.